last recording. All right. Okay, we ready? We ready? A gas is less dense than air and dissolves in water. So it dissolves in water and you're trying to collect it. Which diagram shows the correct method? A method of collection involving water is not suggested because the gas will dissolve and you're going to lose the gas because it dissolves in water, right? And it has to be less dense. It's less dense, so it's going to float in air. So A is out and C is out because the gas can easily escape. Actually, C is out for both denser and less dense because the gas can just easily flow out from this. B is collection method for a gas that is less dense because air will sink, but the gas itself, once collected, will rise, and you can collect it easily over here. So B is your best bet. B. Okay. Question is a bit unclear. What do you mean? You can't see it fine? You cannot see it? Resolution is bad? White screen would be better? Oh, don't say that. I love black. It looks so nice. You're saying white screen would be better? It's because of the... I don't know. Like, I think it's fine on my end. Are most people having this issue? It might be your internet. You're not getting the right resolution if you have slow internet. Okay. And maybe white is slightly better, but it won't make too much of a difference. And I chose purposely black because it's easier on the eyes, especially at night when you're looking at it. Okay, so it doesn't fatigue it. Liba can't see the screen properly. How many of you are having issues with the screen? Just answer, or like do the thumbs up thing. Let me move on to another question. Is this readable? Obear is having issues, Habiba no issues. Just make sure your internet is fine. I'll recommend disconnecting and connecting again. But I've barely had any issues with the screen quality so far. Oneeb, can you let me know how your quality is as well, so I have a good idea? I don't think there's an app. Oh, if you're using the browser, you can connect through your Zoom client, so do that. That might be better. It might not be too good on the browser. It's fine now? Okay. It's fine. I think it's just the internet hiccuping, right? It goes down kind of like YouTube. It just goes down and the internet suffers for a bit. Tests were carried out on an aqueous solution of an unknown compound P. The observations are recorded in the table. The test was aqueous sodium hydroxide is added. A green precipitate soluble in excess. So they're talking about green precipitates are for iron 2 and chromium 3, right? Or just chromium, there's no other variant, right? Now, chromium dissolves in excess. Chromium will dissolve in excess. So they're talking about chromium is present over here, right? My cam is covering the options, brilliant. Whoa. It just gives me vertigo sometimes. Maybe I can, maybe I can't. Okay. So chromium is definitely in there. That's what the first test is telling me. Dilute nitric acid is added, then aqueous barium nitrate. A white precipitate is formed. Barium is a very specific test for sulfates. So they just tested for a sulfate ion. They just tested for a sulfate ion and they have a positive test. So the solution has sulfate ions present. Dilute nitric acid is added with aqueous silver nitrate, no precipitate. What is this a test for? They're trying to test for the halogens, the halides, right? So it's not present there. So you have just chromium and sulfate. The answer is B. That's the worst B I've ever drawn. Make sense so far? B. It's okay now? Okay. Okay, okay. I'll keep my, should I keep my, I can also make it this slightly smaller. You know, like I think in a day or two I'll remove my camera as well because I don't think it serves too much purpose. Heats up my computer. I just wanted you guys to kind of relate a bit. Once that's done, well, I'll just remove this in a bit. Okay, next question. When one volume of gas R reacts with exactly 5 volumes of oxygen, it forms carbon dioxide and water only. So it's a combustion equation and they're just talking about what is R. You like it? It makes the class interactive? Yeah, I think it'll still make it interactive once you know me, right? Okay, maybe 4 days is too soon though. Okay, we just have to make equations. I'm gonna start with ethane, because like, it's never the extreme, right? So this is too large, this is too small. I'm gonna start with ethane, let's see what we get. Then we'll have a general idea. If ethane, like I'll explain it on the way. Let's do it with ethane first. Ethane is reacting, and I have to react it with oxygen and then balance it out. Carbon dioxide and water. Now, you will produce 2 moles of carbon dioxide and 3 moles of this. How much oxygen do I have? You have 4 oxygens here and 3 over here. 3 and 4 make 7, so this is 3.5. And why I chose ethane is probably a bit more clear, because it can be methane, right? I need more oxygen to be used up, right? So ethane to nahi hai, but methane bhi nahi hai. That's how I eliminated it. I could have gone with propane as well, but yeah, okay. So let me cross out the wrong answers. It's not B, it's not C, because methane is lower in carbon. It'll require even less, oxygen. Okay, let's move on to propane, let's see. So if it's not propane, then A is the answer, or propane is the answer. C3, I think propane is the answer. C3H8 reacts with oxygen to form carbon dioxide and water. Am I still talking too fast in high Angrezi? 3 and 4, that's a total of 6, and that's a total of 4, a total of 10 atoms, right? So that has to be a 5. I knew it. D is the answer. Yeah? Easy? Easy? I do talk a bit fast, especially when I'm explaining it. I think I should talk slower. Yes, easy? Oh my mom, what's up? How's it going? Speed was better? Previous speed was better? You're talking? I didn't change my speed. I didn't. I was just saying, I was just asking. I didn't change my speed. Come on. Okay, let's move on. I need something. You guys start with this question. Okay, this question, I think there's no easy way. I think we have to just calculate it for everything. But you can be smart about it. They're giving you the relative formula. You can be smart about it. You can apply the same logic we applied in the previous question. I think it was question 10. Yeah, see, like people like dark mode. I'm just saying it's good for the eyes, and bad resolution doesn't mean you'll still have just as bad, maybe slightly good time if your resolution is bad. That's because of the internet. It could also be my internet, but then all of you would have problems. So I'm just saying it might just be your internet. The relative formula masses of 4 compounds are given. 1 gram of sample of each compound, 1 gram sample of each compound, right? Which sample contains the highest number of moles of oxygen atoms? So I want to quickly find out the moles for all of them. I'm a very table guy. I don't know if you understand what that means. It means I like to think in tables. So I'm going to make another table here and calculate the moles of 1 gram of all of these, right? The MR is there, so I just have to go 1 over relative MR. So it's just 1 over these values and I'll get the moles. I'll calculate this real quick. 1 divided by 102 is 0.0098. 0.0098, then 1 divided by 80, 0.0125, 1 divided by 98, 0.0102, and HNO3, 1 divided by 63, 0.0158. ठीक है, ये हो गया. Now what I want to do is find out the moles of oxygen. I found out the moles of all of these if I had 1 gram of these. What am I doing? How did I find that out? I just went mass, if you're not following, mass over the MR, where the MR was 1, oh sorry, the mass was 1 and the MR was whatever relative formula was given to me. So a mole of oxygen मुझे पता करना है, moles of oxygen. ठीक है? And that's just going to be this number, however, whatever the count is, multiplied by this number, right? And if I do that real quickly, 0.0098 times 3 for the first one. Let's get a good color out. It's 0.0294 moles. This is just going to be 0.0125. 0.0102 times 4 is 0.0408, 0.0158 divided by, oh not divided, multiplied by 3. I think that's our winner. 0.047, yeah. And the answer is D. That's the largest moles of oxygen over here, right? Does this make sense? Let me do the first one, or actually the last one, in detail so everyone gets it, right? Why is Mariam going, yay? Oh, she got it right, is that why? I'll do the first D, the answer D in detail, so you understand what I did exactly. What I did exactly. So for D, what we have to do is first find the moles of HNO3. And I did that directly over here, right? Over here. Right here, over here. And I did that by, because I have 1 gram of it, and the MR for this is 63. And I got 0.0158 moles. But they want to know how many atoms of, how many moles of oxygen I have. Or what's the count of, what is the largest amount of oxygen present in 1 gram of this? So, how do I find the amount of oxygen? अगर मेरे पास एक HNO3 है, right? If I have 1 HNO3, not O2, just the oxygen atom. If I have 1 HNO3, I have 3 oxygen atoms. If I have 100 HNO3, I have 300 oxygen atoms. If I have 0.01 moles of HNO3, I have 0.03 moles of oxygen atoms. If I have 0.0158, I'll just multiply this by 3, and this is what I did over here. So I'll get, multiplying this by 3, I'll get 0.0474. This was the logic to calculate all these numbers, and now we had to compare at the end what was the largest value. Can't I divide, what would that give me? Haris is asking, sorry, too late, sorry. I just didn't realize it was a DM, but too late. Why don't I just do moles, mass, ME? That's what I did. I first did moles over mass. I found this out. Then I also wanted to find out the number of oxygens. Now, how could this question would have been a lot easier is that I would just go, well, like copper is kind of like obviously not the choice, right? Does this make sense? Do you guys get it once I explained it in detail? I don't know if I should answer, Habiba got it, but some people are asking questions. Haris, should I answer your question? Aga, should I answer your question? Or are you getting it? Did you get it? Because that might be a slightly older question. Haris, you got the answer D? Okay. But you're saying something else, and I don't want to spend too much time thinking about it. But you're saying that why don't you just divide, I'll tell you why. I'll tell you why I did this. Okay, the idea is, let's say you have 2 molecules. 2 molecules, right? And let's say they're both, you have copper oxide and carbon monoxide. Now what's similar in them is they both have the same amount of oxygen in them. So what you have to do is find out 1 gram में इन दोनों में से कौन से molecule के पास ज़्यादा होगा oxygen. So you first do the mass ratio, how you are thinking, Haris. You do the mass ratio. But what you also have to realize is that, let's say the mass ratio is telling you 50% of all oxygen over here is going to be oxygen. Oh, sorry, 50% is oxygen out of the entire carbon monoxide. And over here, only 10% is oxygen, right? But when you calculate the moles, let's say you found out there are 1,000 atoms of or molecules of copper oxide, but you have only 10 molecules of carbon monoxide. And this carbon monoxide looks like cobalt, so I'll rewrite it. So 10% of 100 atoms is going to be 100 atoms, and 50% of 10 is going to be 5 atoms, right? So even though the mass, the oxygen to carbon ratio is higher over here, it doesn't mean the entire thing will be a lot more in quantity. That's what I'm trying to highlight. I hope you understand this, but yeah. Okay, I think people are a little distracted in the chat. I don't know what you guys are talking about. But Horace, do you understand why I did it this particular way? You got it? Okay, brilliant. Let's go back to the question. Okay. This question. Let's try this out. For some people, they'll say they'll easily rule out a few few options very easily. Okay. For me, I can easily rule out D. I can also easily rule out A just from sheer memory, because okay, a lot of people are getting the answer right. I don't know how. I found this a very difficult question. Okay. Now, why did I rule out A? This goes with your understanding of electrolysis. Now what's going to happen is, more likely than not, copper will deposit on one of the electrodes. So it won't produce a gas, right? What's happening here is it's producing gas in a ratio 2:1, because the volume occupied by the gas is 2:1. And just by looking at it, you can go what gases they're talking about, right? Okay. If you work it out, if you think in sodium chloride, hydrogen gas will be evolved and chlorine gas will be evolved. That's a strong possibility. Actually, that's exactly the possibility. But you'll also realize they'll be evolved in the ratio 1:1, right? And if that was the case, the height of these two columns would be exactly the same, because equal moles are produced. With dilute sulfuric acid, what happens is oxygen is produced and hydrogen is produced, and they react. They are produced in the ratio, if I get this right, I think they're in the ratio 2:1. 2:1, does that seem normal? Yeah, I think that's fine. So this has to be hydrogen, this has to be oxygen. Does this make sense? And the reason for it is not because it's H2O, I guess you can say that, but it's actually to do with, do you guys want me to explain why it's in this ratio? It's actually to do with the chemical formula. When hydroxide ions, when they discharge, they don't form oxygen. They form water and oxygen and produce electrons. And they produce 4 electrons, and this is one of those equations you need to know. If we had P2, I would tell you to ratify this equation right now. But even if you don't have P2, still ratify it. Or like understand it. And once you balance it out, you'll see this is produced in the ratio 2:1 for every 4 hydroxides ions. And on the other side, what happens is hydrogen ions absorb electrons and produce hydrogen gas. So the ratio over here is 2:2. Now the electrons absorbed by the OH or produced by the OH ions are whatever the amount is also needs to be the same amount absorbed by the hydrogen ions to form hydrogen gas. So if you multiply the second equation by 2 to balance the electrons out, let me do that right now, you'll realize the ratio of the gases change. Right? So hydrogen is being produced twice as many times for each oxygen produced. This looks like 10, so I'll just hide this and rewrite it as the number 1. I know, I don't want to say rectify it, but at this point in time, if you don't care too much about it, just rectify it. If you don't want to rectify it, the idea is the hydroxide ion, discharges, it reacts to form water and oxygen. Now you're told that hydroxide ion produces oxygen directly. That makes it difficult for certain questions. Questions like these, it'll make it difficult, right? And you might associate the false understanding that it's happening in this ratio because the chemical formula for water is H2O. Coincidence, nothing else. What's really happening is it actually produces, for every one oxygen produced, it's also producing 2 hydrogens. And the reason is, when you balance the electrons out, this is what happens. Okay. Once you understand that, you also should be able to understand, okay, if this is discharged, it'll definitely produce water and it'll definitely produce oxygen. Now, this reaction happens underwater and water is formed as a liquid. So you don't see any liquid being formed here because it just adds to the solution. But oxygen is a gas, so you see bubbles of that around the electrode, and you can collect it if you want to by using a boiling tube on top of it. No, you cannot write minus for E. Teenage mind, you cannot write it like that. You always add plus electrons somewhere. So if you mean minus, you put it on the other side, right? Plus over here does not mean you're adding these two together, right? Let me give you an example. Let's say calcium carbonate is decomposed by heat to produce calcium oxide plus carbon dioxide. In what way is this telling you that calcium oxide reacts with, you're adding carbon dioxide to calcium oxide. This doesn't mean anything. This doesn't mean add. This is just a way of writing comma in a fancier way, right? This is actually a comma for chemists. If you want to be a grammar Nazi, this is actually a comma. This does not mean plus. You read this as calcium carbonate thermally decomposes to form calcium oxide and carbon dioxide, and that's what you're saying. This doesn't mean these two plus, it's not add, it's not maths. Okay, does this make sense? Shall I go back? Shall we continue with our studies? Or do you want me to explain any part? In detail? Continue? Habiba says continue. I'll just wait 30 seconds for anyone to ask any questions. Yes, sir, I wrote before the arrow. No questions? No, it's fine. I hope you guys got it. Okay. We just eliminate what? No, this is happening, the OH ions, this happens for every time OH is reacts at the electrode, but we just say oxygen is produced for OH ions. We don't look at the reaction in detail. And this is one place where the reaction in detail, helps you what's going on. We can also eliminate all options to get yes, to get C. Now, yeah, essentially, yeah. But in exam times, won't you be confused with, that's the easier way to do it. I was just explaining it because, people don't understand this too well. So we can also say that it can be concentrated as it needs free electrons, neither molten to transfer. Concentrated does take place. The reaction of Brin is part of your syllabus that you purify, you produce sodium or chlorine from Brin, right? So concentrated does take place. The only difference is that the cation that's discharged is actually the concentrated one. So over here, chlorine will be discharged instead of the OH ions that are also present. Okay. Now, Fatma, I understand what you're saying. Fatma's saying we don't have to understand this. That's why I'm mentioning this equation here. I know you guys don't have theory, but go through this equation. If you can't remember it, it's completely fine. But if you can remember it, know it, because it'll help you. That's why I'm suggesting it. I'm not, giving you random statements. I'm giving it to you for a reason. Okay. Anyway, enough time on this question. We'll move on. Which statement about ionic compounds is correct? This is too easy. Ionic compounds conduct electricity when solid because they contain, well, this is just wrong. It doesn't conduct electricity as solids. Ionic compounds consist of lattice of positive ions and negative ions. This is absolutely true. But I'll read other options as well. Most ionic compounds are solids at room temperature because of strong attraction between electrons and positive ions. That would be true if it weren't for B being true, because it's actually the attraction between positive and negative ions that is strong. What they're talking about here is probably metals, more suited for metals anyway. When molten or in aqueous solution, ionic compounds conduct electricity because they contain electrons that can move. Actually, it's the ions that are free to move, not the electrons. This also answers, I think, Fatma's question, or someone else was saying, hey, concentrated mein electrons nahi honge. It's not about the electrons, it's about the free ions that are free to move. Concentrated or not, the ions are still free to move as long as the ionic substance is dissolved in the water. And if it says concentrated, that by virtue means it's dissolved. You need something to be dissolved first, then it becomes concentrated, right? So any concentrated solution of ionic, compounds will conduct electricity. Okay, B is the answer. Everyone got that. 17. A lot of people got this wrong. I can empathize why I would get this wrong as well if I didn't study chemistry for 2 months, because these names are confusing. The correct answer is C. Oh, sorry. I think it's not C. Yeah, it's D. Okay. And the reason for that is how I've justified it to myself and how I would like you to remember it is, butamin is a very common example that shows up in O levels, right? In geography, you study butamin as well, right? Don't you? To make roads? I think you do. If you don't sue me, right? Diesel, we know it's a fuel, right? Now, naphtha, no one knows about, but naphtha is the name given to petroleum compounds. Naphtha, not naphtha. Naphtha, how do you spell naphtha? Oh, there are 2 H's. That's why I was confused. This is the raw material petroleum that goes to the plastic industry, right? Naphtha. So used to make plastics. So that's what you normally associate this as, not for making roads. Any petroleum that can be utilized to make plastic is by definition called naphtha. Okay. So the correct answer is D. D is, and most books say it's used for aircraft engines, which is also true, but there are different kinds of aircraft engines. Another use for kerosene is to heat, use it as a fuel. Okay, does this make sense? lamps. I am recording this lecture. A compound decolorizes acidified potassium manganate. What could these compounds be? Yes, Ava. Guys, can you do me a favor? There's a lot of feedstock is another word for raw material that goes into the industry. The last one has to be an alkene because it's called kerosene. Okay. Yes, Ava. Can I ask everyone to write a question in one line? Because if I get a question in 3 different comments, like a WhatsApp message, you guys need to realize I'm getting 30 messages, right? And a lot of the DMs you guys don't see. So yeah, I think people have it. Magnesium chloride. Magnesium is not a transition element. Transition elements have multiple oxidation states. Over here, the oxidation state of magnesium is 2, and it cannot be further oxidized. It can be reduced though, but we're not talking about reduction, are we? We're men of culture. We talk about oxidation only. Iron 2 can be further oxidized to iron 3 just by using a reducing agent. And ethanol can be oxidized to what? Ethanoic acid. So the answer is 2 and 3. And what are you saying? It's not. Right? Let me check. We don't have plastics mentioned here. Someone's talking about how the correct answer for the last one is C, and I strongly disagree, but yeah, it's not. And I think you forgot what the answer said, because you're saying something else and the answer is something else. I'll move on now. ठीक है. 20, I think straightforward. I won't go for further explanation. Which one? 20, question 20? No, sorry, Fatma, I didn't read your comment earlier. Decolorization doesn't mean, this is KMnO4, guys. This is a very famous oxidizing agent. You're meant to know. This and potassium dichromate. The color change for this is purple to colorless. And this is an oxidizing agent, meaning it'll react with anything that is oxidizable, right? So if it shows a color change, that thing can be oxidized, right? So you have to figure out what things can be oxidized. Can magnesium chloride be oxidized? No, it cannot. It's in a Mg2+ state. Like, can magnesium be oxidized? Yes, it can. It can turn into magnesium 2+ oxide. But this cannot further react to form any other oxygen state. Why? Because group 1 and group 2 have fixed oxidation states. Mg2+ can go back to Mg, but that's not oxidation, that's reduction. KMnO4 won't do that. A reducing agent like maybe hydrogen will. Okay. Can the second one be oxidized? Yes, it can. You know about iron 3, right? And if you don't know about this reaction, this is one of those reactions you can kind of do in the lab. Like if you have a green precipitate and if you throw KMnO4 onto it, it'll turn red because the iron 2 ions, which are green, will turn into iron 3 ions, which are red, brown red in color. Okay. Ethanol can also be very famous for being able to oxidize. You can oxidize it 2 ways, either with KMnO4 or the natural way using fermentation. Okay. Fatma gets it, people get it, I hope. Okay. Yes, okay, let's MVPE on. Okay, move on. Okay, fine, jeez. It's okay if people are getting it. Let's try this question out. Pure lead sulfate is prepared. Whose answer in the last class did I not answer because someone gave me not a bad review or anything, but someone said, I'm sorry I didn't answer because, 10 people are talking and I can only look at the comments and not be distracted, like we're trying to have fun as well. So I'm sorry if I didn't answer your question. I hope I don't ignore your question again. Yeah? Okay. So you're mixing two things. Which row shows the best way to precipitate lead sulfate? Now, honestly, when I saw this question, like, how dare they? It's such a difficult question. But the more I read it, I was like, this is very easy. Okay. Now, one thing you should know is that you're trying to make what are you trying to make? Best way to prepare pure lead sulfate, PbSO4. You're trying to make PbSO4. What is the best way? Now, best is also an issue. Okay. Because what was I gonna say? You might be able to make lead sulfate from more than one of these steps because you want to have the best way. Okay. Now, okay. Dilute sulfuric acid. Why is this such a bad idea? Carbonate with an acid. Actually, I forgot why this was a bad idea. What happens to a carbonate when it reacts with a carbonate? Releases carbon dioxide, too reactive. The issue with this is there could be it's not the best way. Because I say this, because yeah, I forgot why. Now, I think the reason for this is there might be, if this is insoluble in water, both carbonates, right? And if you add acid to it, you probably won't know when the reaction is done because this is a solid and your lead sulfate is a solid as well. So either way, this won't work. You won't know. It's not according to the diagram given. Like you can mix it together, then you can throw it, and the issue is that, yeah. I think that's the issue. Dilute sulfuric acid. Let me read it over here so it's more comfortable. Solid lead carbonate, solid crystal. Which row is the best? Which row is the best? Yeah. Yes. Okay. Yeah, I don't see someone doing that because there's a much easier way to do it, which is actually in options A and B. If you take lead nitrate, which is soluble, and sodium sulfate, if you mix them together, lead sulfate is formed, which precipitates, right? And that's what they want you to go for, this precipitation reaction. Yeah, right? So I think one logic is that the two reasons for not selecting C and D. One is that you will never know when this completely dissolves, right? Because you're adding sulfuric acid and you're also forming a solid, so it's kind of tricky. The other thing is that this is a textbook reaction, where the reaction forms a precipitate. Okay. And the only thing they want to ask after this is that, is this your final salt that you want to extract, or is this it? And the correct answer is, because lead sulfate is a solid, you wash and dry the residue. This is where the lead sulfate is. You wash it and you dry it. And the answer is B. Does this make sense? I think I'm feeling I'm not giving a satisfactory answer for this question. I'm a bit confused about this as well. Why is option A not the answer? Because lead sulfate will not be soluble and it will not pass through the filtrate, right? And once you filter it, it's insoluble, so it will be left behind, and you pick up this residue and you dry it out. It's a salt preparation question, right? Most sulfates are insoluble, or you can go with all sulfates are insoluble, as all nitrates are. Oh, I think I messed up my phrasing. Insoluble, most sulfates are insoluble, and all nitrates are soluble. That's what I meant to say if I messed it up. Okay, I think I'm not doing a good job explaining C and D, but I'll come back to this. I'll answer in the next class or leave a comment on this under the video. I'm kind of stuck in a rut as well as to why C and D aren't the best choices. Okay, for now let's move on. Conservation of time. I think this is an easy question. I don't know why this is here. Okay, which statement about brass is correct? It contains a sea of electrons. Well, that's true. It contains positive ions, negative ions, which are free to move. No. Right? They're talking about ionic compounds. Brass is an alloy. Alloys are just mixtures of two metals. It's just a fancy word of mixtures of two metals. And they'll because they're mixtures, so they're not chemically changed, they'll each behave like metals. And A is already our answer. It is a compound of metal and a non-metal? No. Two metals. That's what an alloy is. It is a compound of two or more metals. No. It's not a compound. Okay. The answer is Fatma goes O. Why is Fatma going O? It's a mixture. Alloys are mixtures by nature. But what do you do if you melt two metals, mix them together with a chammach and leave it to dry? Like ice cream. Milk, probably not the best example because milk is already a mixture. But milk and water, if you mix it and freeze it, ice cream is a mixture technically. A mixture of different chemicals, different compounds, but it's a mixture. Right? And that's the idea. That's a weird question to ask, Masa. Iron is obtained in a blast furnace from the ore hematite. What is hematite? Primarily impure iron 2 oxide. Which process takes place in the blast furnace? Calcium carbonate is used to remove acidic impurities. And that's absolutely true, but sometimes these questions are confusing, so let's read everything else. Coke is reduced to carbon dioxide. That's true. Everything is true aside from the fact that coke or carbon is oxidized to carbon dioxide, not reduced, right? The word is reduced. Hematite is oxidized to carbon monoxide? No, bacha, hematite is reduced, right? You guys know what the difference is? Oxidation, reduction. Hematite undergoes thermal decomposition. If that was the case, why would you add anything else? Am I right? If it can thermally decompose. You never concentrate like that, Sadia? Khatija, what are you saying? Can we block Khatija? Manib, can we block Khatija? I can't remove those people. I don't have access to it. Let me message people. Always fun. Which pair of gases are both non-acidic? They both have to be non-acidic. Ammonia is alkaline and methane is not acidic, right? How do I know? Well, I mean, you think they talk about, then your, farts might bring down the pH of the room, right? How many of you, on a scale of 1 to 10, think that's a horrible joke? 1 being horrible, 10 being brilliant? Rate me right now. Okay, it's A, the answer is A. What did I say about D? Minus 20, I'm sorry. Fart jokes, no, not cool? Okay, fine. Okay, let's see if we can do another paper. Now this is your variant and you'll realize a lot of questions are exactly identical. How do we know about methane? Well, that's an interesting question. Methane, I mean, you've seen methane up close, right? You've seen organic reactions. Have we ever talked about methane being acidic? There's only one kind of category of compounds in organic chemistry which are acidic, which are carboxylic acids. So, I don't have to tell you each and every element that's not acidic, right? Like, is a rock acidic? Is my car acidic? Like, I don't know, you never told me. Like, but I don't have to tell you, Chemistry is kind of ratta. It's not ratta, but like you can use common sense to it. Nah, how was that ratta? Methane, like, don't you guys know why methanoic acid is an acid? Because in water, it forms methanoic ions and hydrogen ions. And it's a weak acid because it's a reversible reaction, right? Hydrogen ions are produced, and that's what an acid is. In a reaction, it produces H plus ions. This is the nasty bugger that makes an acid, right? So I'm removing this hydrogen. I'm not removing any of the other hydrogens. What does that tell you about every other hydrogen over here? They don't get removed when they're dissolved in water. And the other thing is, another logic you can go, most alkanes and alkenes are insoluble in water. How can you have an acid that doesn't dissolve in water? ये सर से गुजर जाता है? I think it's a little late for me to lecture about this, but it's very easy. I did make a few videos on YouTube, so you can check those out if you want, like old videos. But the quality is not too good, so you'll hate me for it. So, but yeah, I guess if you want, you can. But no one, they're actually class recordings, so no one's gonna watch them, I think. But oh well. Okay, what's the essential apparatus? C and D, they're talking about titration for some reason. You don't need a pipette, but you do need all of these. And I think a thermometer and a clock is missing over here. Right? No, chem is not just ratta, it's a mixture of ratta. But guys, you need to understand you do these things for most things, right? If anyone's into cooking, like you use some basic, like learning the language, don't you ratify your ABCs? Who tells you A, B, C, D, E, F, G? Don't you ratify for the first 3-4 years of your life? Then you start using it and get really good at it. That's the idea. So if you say, like, a lot of people are allergic to maths because says, oh, I'm not a math person because it's too technical, it's too numbery, and they don't realize it's just their basic understanding that's slightly off, and if they practice their ratios, fractions, and addition and subtraction really well, in like 3 months they can start studying maths, they can do really well, right? And if you understand math really well, half of your studies is easy for you. Because if you nail math, physics is done. Most sciences are easy to process. Economics and accounts is easy, right? Chemistry, there's rata, but once you understand there's a base rata, you understand it, then you can do great things with it, right? And if you've seen some cool things people do, like there's one YouTube channel called Nile Red. If you check the stuff he does, I find it so fascinating, the amount of stuff. And he goes like, what if I take this and I mix it together, it should turn into this. And this guy like makes gold out of, medicine. He takes medicine, mixes it together, and it turns into gold, and I understand what he's doing, so I think it's a little high level. But if you ever get the chance, watch this channel. Most people might find it boring, but some of his videos are really interesting. This a thing called a mercury, it just looks like a solid smoke, and it has mercury in the title. If you watch that video, I dare you to be not shocked by it or not be awed by it. I've seen Vsauce. I spent my life growing up with Vsauce. I've seen all of Vsauce. I don't watch it anymore because it's always, hey, Michael here. It's just weird. Okay, moving on. Let's try this question out. I think this is also really straightforward as well. Nile Red is not me. He's a really smart guy. I don't know who he is, but I think he's really smart. Very committed to his work. I'm going to start uploading this. I'm going to upload this to EdMatrix. I do upload a lot of content. I have videos, I have notes, but notes, I don't want to say it because they're incomplete right now. And I mean, hey, they're notes. Post my notes. They're only meant for my school kids. I'll think about it. I'm sorry. Hey, I don't have notes for ATP, sorry. Because school, we opted out of ATP, so I never made them. Okay. And the answer for this is people were just confused that this is actually a reaction between ammonium and HCl to form ammonium chloride, which is a solid. Okay. And the answer is then, this is correct, this is correct, this is correct. All three are correct? A is the answer. Right? I think organic questions are easier than other questions, and we can do them. But one thing I want you guys to note is we saw variant 1, which had the 10 most difficult paper questions in that year. Mostly it's not the organic questions that people find, they find it tricky and difficult, but they are able to solve it. But when you're looking at these little weird questions, most of the questions we did, they were the 10 most difficult questions, and there was not one organic question over there. Organic, I wouldn't say organic is easy. People find it difficult, so I don't want to, say, oh, it's easy, like be that guy. But questions, you have to be visual about it. Organic, yahan pe, like everyone has like that organic, de kara dein sir, and moles karwa dein, or notes de dein, like these three things, that's all I hear all the time. Not to highlight anyone right now, I'm not calling anyone out, that's all I hear. Yeah. Okay, which statement about the structure or bonding of metals is correct? Metal is latticed, consists of atoms in a sea of electrons, that is correct. I don't know why people found this difficult. Wait, B, a metal Lattice consists of atoms in a, ions, not atoms, sorry. This is the incorrect part. Sorry, my bad. Wasn't reading properly, I was distracted with the chat. Electrons in a metal move randomly through the lattice? Okay, yeah, fine. It is indeed B. Metals are malleable because the particles present are mobile? That's not the reason. Right? They're not mobile. Particles are not mobile. Electrons are, but they slide over each other on impact. The ions in the metal move when positive and negative electrodes are attached. No. Not even. Moving on. Repeated question. This is the second variant, the paper you would have done if you were sitting for the 2018. And look, repeated question. This is the same question we just did, right? I'll skip it. Look, repeated question, right? The variants are identical. You should be doing all variants if you want. It's better to do all variants and do less years of past papers rather than do more years of past papers and do the same variant. Because later past papers will have more used questions and older past papers will have more probability of outdated questions. And that's a repeat as well. Okay, photosynthesis is shown. Which statement about photosynthesis is correct? It has a negative enthalpy change. Does it? I don't know about you guys, but doesn't it need energy? Doesn't it absorb energy in the form of sunlight? So shouldn't this be an endothermic reaction technically? Right? It is catalyzed by the presence of yeast. Oh, that's some other reaction they're trying to confuse us with. The products of photosynthesis are oxygen and starch. Close, it's actually sugar. The sugar is later processed and turned into starch. It occurs in green leaves. Well, okay. What is, it's like, which of these statements is true? The mass of the sun is 2,002,240. The Earth's revolution is 23.4 pi radians per second, and oxygen is colorless. It's like, sab kuch kar diya, it occurs in green leaves. Okay, fine. It's exothermic? No, it's not. It's endothermic. What are you talking about? Photosynthesis is not exothermic. Really? I'm Googling it right now. I don't believe for a second it's exothermic, but I'm Googling it. Is photosynthesis endothermic or exothermic? Endothermic reaction. Respiration is exothermic because the same sugar is burnt. So it's technically the reverse reaction of this, guys. So the reverse reaction has to be exo. Am I right? Am I right? Say I lamau if I'm right. I lamau if I'm right. A lamau. No, I meant the AYE. Not ilamo. All right. Tika, let's complete this paper. Which reactions involve oxidation and reduction? Your true knowledge for oxidation and reduction. Before any paper starts, मैं सबसे पहले दुआ पढ़ता हूँ when they tell you to start, and मैं सबसे important चीज़ें रख लेता हूँ. Oxidation and reduction always confuse me because they're kind of ratta. But once you know that ratta, you can apply it. How do you eliminate that? Here's what I do. I say oil rig, of course, right? What does that tell me? Oxidation is loss of what? And reduction is gain. Let's get fancy. Let's get a little festive, right? Reduction is gain of electrons. Oxidation is increase in oxygen, right? How do I know that? Because it's freaking called oxidation, right? Increase of oxygen. So this has to be the opposite of it, decrease of oxygen. Then the last definition of oxidation or reduction, as I remember it, is hydrogen. Now hydrogen I know as, this is balanced. If I remove this definition, एक का increase होता है तो दूसरा decrease होता है. That's how I remember it. So when I'm talking about reduction, it's loss of hydrogen, which is if I'm talking about oxidation, loss of hydrogen is oxidation, whereas gain of oxygen has to be reduction. Opposite of oxygen wala, right? Opposite. That's Greek for opposite. Okay, ठीक है. Chlorine gas reacting with aqueous potassium iodide. Chlorine will react from iodide to form, I won't even bother balancing it, to form KCl and iodine. Iodine is going from -1 to 0, right? Or you could say this is going from 0 to -1. So this is reducing, this is oxidizing, right? How do I know oxidation state is changing, right? Now, one thing to know is that if something is reduced, there has to be another thing that is oxidized. Why? Because oxidation and reduction is just gain of or loss of electrons, right? So let's say I go to a store and I buy, let's say, like a bag of chocolates for 1,000 rupees. I got poorer by 1,000 rupees, money-wise. Can I say the store got richer by 1,000 rupees to make them neutral? Can I say that? Fatma Noor says no, breaking my heart. Why not? I mean, you can. I mean, it's a rhetorical question. Let's say you can, all right? Like, I gave them the money. Didn't they get richer? Don't bring the, but chocolate is, like there's a net difference is 0, because if we only follow the money, he got richer by 1,000 rupees at that moment in time, and I got poorer. Or if I gave Fatima 1,000 rupees, right, for making me think twice about my, right? If I give Fatima 1,000 rupees, she says thank you, appreciate it, right? I got poorer by 1,000 rupees and Fatima got richer by 1,000 rupees, right? So for anyone getting poorer in any transaction, someone has to get richer. And that's what a transaction is. It's a transaction. दो लोगों के बीच, right? I never got my chocolates. Fatma will be held accountable on the day of judgment, on this momentous holy day, in this holy month. She never gave me chocolates. Okay, back to the serious thing. So if anything is ever gaining electrons, someone else, somewhere in time, has to lose those electrons, because electrons are the currency of atoms. What the hell is that? Thank you so much. Thank you for the chocolate. Okay, do you guys understand? If you guys understand that logic, you have to identify just oxidation, and वहाँ पे reduction भी हो रही है. Dilute sulfuric acid reacting with magnesium. अब देखो मैं क्या कर रहा हूँ यहाँ पे. Magnesium reacting with sulfuric acid will form magnesium sulfate, और उसका charge होगा Mg2+. So this has reduced. This has oxidized. So somewhere has to be reduced, and we can figure that out. I believe it's the hydrogen in sulfuric acid which is reduced, and we can work that out. But we can take a leap of faith over here. Once we understand something, we can start growing over it, right? Once you know your ABCDs, you can start going to vocabulary without thinking about ABCD, right? Too broke to buy all the chocolate, was still stuck on chocolate. Take it. So magnesium, if this is oxidized, something else is reduced, and this involves oxidation and reduction. Any oxidation reaction is technically a redox reaction. Any reduction reaction is also, by definition, a redox reaction. This is a briefer way of my entire explanation on this question. Okay? Dilute hydrochloric acid reacting with aqueous sodium hydroxide. Let's work this out. This is actually not a redox reaction, and I know this because I know this equation, or these sort of equations, really well. What's happening is hydrochloric acid reacts with sodium hydroxide to form NaCl and water. And if I take a closer look, let's take a look at what's happening to hydrogen. Hydrogen is over here, which turns to Cl minus ion, and it's the H over here. So the H plus and the Cl minus over here, which is already plus and minus, is still Cl minus and H plus, right? And the NaOH over here, and OH, it's easier to think of the entire thing as one thing. It makes your life easier because it acts as one thing. Those are the charges on it, and the sodium still has that Na plus charge, and the water, if you think of it as an ionic substance, it's not really, but if you think of it as an ionic substance, has that negative charge. So there's no change in oxidation numbers at all. So this is not a redox reaction. You cannot see oxidation or reduction taking place over here. I wanted to cross it out. Okay. This is actually a neutralization reaction where an acid meets a base. And all neutralization reactions are not redox reactions because the same thing happens in all of them. Stop talking about chocolates because people are talking. Might have questions. Yeah, Fatma called it. Stop talking about chocolates before I throw shoes at all of you. What's your favorite chocolate? Achha, people, if you have a legit question, make it all caps so people can still troll and have fun. But if you have a question, make it all caps. And people who don't have a question or anything urgent, do not say anything in capital at all. Don't even capitalize the first word of your sentence. Agreed? Let's move on. Let's try to complete this today while we're young. I'm already tired. I have to go to the gym at 12. Which pair of reagents are most suitable for, how many people do we have right now? 31, look at that. Which pair of reagents are most suitable for the lab preparation of copper chloride? What do we think? A very similar reaction to what we had last time. Oh, rosa lagega. The issue with over here is this is not aqueous. This is actually solid. So it won't react in a solution. So it won't displace it. Copper and chlorine, I mean, there's no such reaction we've ever come across. Maybe it does happen, maybe it doesn't, but you know, who knows. Copper and dilute hydrochloric acid, this does not work. Do you guys know why it doesn't work? I'm sure most of you know. Copper oxide is basic in nature and it will react with hydrochloric acid to form. Why not C? Brilliant question. Do you guys know about metal displacement reactions? Let's assume hydrogen is a metal for some reason. The reason being A, it forms a positive ions, and also it has a honorary mention in the metal reactivity series. And if you remember your metal reactivity series, somewhere near the end there is hydrogen, then there is copper, then you have like manganese and silver and whatever, gold and platinum, right? So copper is below the reactivity series in hydrogen. So if copper is placed in a reaction with something that has chlorine, will this copper be able to displace it? This hydrogen, it will not. Because copper is less reactive than the hydrogen. Only more reactive metals can react with the hydrogen and displace it. That's the logic. So gold is actually immune to acid. Gold, copper. Do you guys want to see something cool? Do you guys know what copper color copper oxide is? The good color, not the bad one. These cups are copper. They're given to me by a friend. They're copper. So you can see it's how it's, the light is very poor in my room. So you see like all of this is, that bright pipe copper you see, like the wire one, right? Now all this, it's actually a really nice blue. My room is very dark. If you saw it in person, I'll try sharing pictures of it. It looks black to you, but it's a very nice rich blue. This blue is copper oxide forming all over it. This copper is actually rusting in my room, and it forms a very nice patina of copper. Patina means texture, right? And this is not a bad thing compared to like iron rusting, because copper oxide is much stronger than iron oxide. Iron oxide has no integrity, so it forms a nice little, compared to copper oxide forms a nice little layer. Do you guys know one very famous so-called building that is all copper oxide? It's technically copper rust. Why isn't the answer A? Because sodium chloride, why was I thinking this is silver? It's not, I was thinking silver. Sorry, my bad. Why will this not react? Because this will because copper chloride is aqueous, I believe. So you cannot separate the two. Which question again? Lady Liberty, yeah, that's right. Statue of Liberty was originally pink in color, metallic copperish pink. It was made of copper. Now it's all coated with green because it's exposed to all that ocean humid air, right? Over time it oxidized, right? And they don't clean it because A, it looks really nice, and if they clean it, they're actually cleaning, and oxide is actually removing the last layer from it. So over time, if they kept cleaning it, if they clean it once, they have to, clean it over and over again. So over time, the Statue of Liberty would, dissolve, so to speak. Time bhula nahi, I wanted to complete one paper and I wanted to, go over most things. This is a repeated question. This is a repeated question, right? This one. Here you go. In 2 papers, this is our first organic question. Sir, can you bench 145? No. Oh, yeah. Oh, yeah. What is the answer for 23? It's D. 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 Is that my catchphrase now? Oh, yeah. Oh, yeah. Ishal's screaming. Agha Hamza, what are you talking about? What question do you want me to repeat? How do you pronounce it? Bro. Straight chain alkane undergoes addition reaction. Now, what you have to understand is that bromine, yesterday I found out bromine is extremely toxic. I did not know that. Okay. What you have to know is that bromine, when it comes and attacks an alkene, it attacks it because of the carbon-carbon double bond and tries to react with it. Now, when this takes place, the double bond breaks because of the attack by the bromine, and once this goes away, that same carbon where the double bond was present, one of the carbons extends a hand of peace towards one of the bromines, and the same thing happens to the other bromine with the other carbon, because both of them can make one bond, and each bromine is free to make one bond, so they end up making bonds. So once you know this, will you ever have a molecule that looks like this? Will you ever have a molecule that looks like this? Why and why not? Why or why not? Mabromine, 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 mabromine. Maham, what's your question? I have made detailed videos on electrolysis and uploaded on YouTube, but the quality isn't that great. You can watch it. I think Miral was sharing the link. Miral, can you share the link to these guys? You can ask Miral. Miral watches our videos. Okay. You'll never have this molecule because the carbon-carbon double bond is between two carbons which is right next to each other, and the bromine will always be joined into the molecule right next to it, right? Now, you could have something like this. The bromine could be here instead of here. But if you understand your, organic, putting the bromine here or here means the same thing. It's not different, right? If you understand that, but I won't explain that wala part. So A is out because the bromine is on extreme carbons. One is on this carbon and the other one is on this carbon for A. If I'm not too wrong, right? Yeah. For B, it's on this carbon and this carbon. B is the correct answer. For C, it's on how I've drawn it over here. This is C drawn. For D, there's no second bromine. There's only one bromine. It has to have two bromines. You got it? Easy. Once you understand it, it's like trivial. You do like 20, 30 questions of these, you'll be like, halwa yaar. No, it ain't. Maham, what's your question? I asked people to ask questions by capitalizing their words. Fatma, your cat is also distracting me, if you understand. What do you like? Why are you mentioning your cat like distracting me? Mujhe de do. Mahuma? You love Mahuma? I love Mahuma as well. Maham, can you ask your question again? I've lost your question. Trying to find your question. I think we're done. Yeah, we're done. We did 2 variants. We're done with summer of 2018. Let me just go over some comments. I can't find Maham's comment because she didn't capitalize. I asked people to capitalize. Oh, okay. Yeah, ठीक है. Okay, are we done? No questions? I think everyone's tired and defeated. My trainer's calling me. My gym trainer's calling me. All right. I hope you guys enjoyed it. I hope you guys understood it. I know I couldn't get into detail for a few questions, but they just involve too much theory. And next class on Wednesday, we'll have an ATP class. Okay? This was the best chemistry class you ever had. Yeah, just say it like you mean it, man. Yeah. All right. Some people hate me too. So you so cool. So you so cool. Someone teach me how to say YHHH. What is that? Oh yeah. Oh yeah. OHYH. Oh yeah. How do you say it? Why is mom yelling at you? Sir, why so call? It's on, yeah. Adam is, okay. Notes plus? Never. I don't know, I'll think about it. I can't really, because I'm using it with another website. Another one, they have rights to the notes. So I can ask them and you can use the notes there. Okay. Bye-bye guys, have a fun whatever. This class was way longer than it should have been. Okay. Sorry about that, but I think most people enjoyed it. And I wanted to keep, I just got lazy. Bye, see you guys, bye, bye. If you have questions, do make the, I really enjoy, I don't know, like taking a class is tough, but I'm, like when I'm commuting, when I'm not doing anything, I just tend to go over Instagram. I'd rather answer your questions. So if you have questions, put it on the platform. I think you have a really good way. Just make sure it's in a neat, presentable way. I value, like if it's like a question where you're, the shadow of the phone is coming up, sab kuch phata hua hai वगैरह, find a better way of sharing the question, right? Take a screenshot of the paper from rough paper and share it or something, I don't know. Make it clean, don't have it ulta, seedha, landscaped, make it, proper. And ask those questions. If I don't answer, someone in the group will answer and you will have your social learning. I don't know how you can share, not on Insta, on EdMatrix. Don't you you can ask questions as a community. Chocolates? Okay, my favorite, I do like Kit Kats, but the good Kit Kats. For some reason, they're bad Kit Kats as well. I don't take sugar anymore, Vasa. But I won't mind getting chocolates. Let's just make it easy for everyone. Ferrero Rochers if you guys get A's in chemistry, right? Can't go wrong there. Okay, bye-bye guys, take care. Bye-bye guys, take care.